Hello, this would be the second video for intermittent IV infusion. I'll try to keep in 10 minutes. For this reason, I have a stopwatch in front of me. So today we will be talking about Cmax, how to calculate Cmax and Cmin. Also, we will understand what is the difference between Cmax and C0 in case of intermittent IV infusion, and we will learn a new parameter, is delta T. So let's go back to the first important equation. Is we'll use this equation to calculate my Cmax and Cmin. So one of the important parameter, that you can calculate my Cmax. You just rearrange this equation. In next slide I will show you. But this delta T is in fact this one. This would be your delta T in case of Cmax, and in case of Cmin you have to use this. So if you know this delta T, it's easy. You just use C trough concentration to calculate my Cmin, and you calculate you know C peak concentration, C peak, then you can calculate easily Cmax. So again, this is the time we have to find out. So now in this case, as you know, this is for this chart is for after first dose, and this is at steady state. So to calculate my Cmax in case of intermittent infusion, we will use this equation, and this equation to calculate Cmax, you have to change the side, and as you can see, the Cp could be on the top, and here in the equation sheet, this is the equation. Let's see. Here's those. In fact, these are the equation I will be talking about today. So now to calculate delta T, always you have to do some mental math. Mental math is, as I have said, delta T is nothing but this is Cmax and Cpeak. So this would be your delta T. To calculate delta T, you have to remember the infusion start from here. For example, at 7:30 you started infusion. Okay, to calculate, you started infusion at 7:30. Infusion at, assume that it is 7:30 when you started your infusion, 7:30, and then when you stop, it is 8, and the Cmax is when you stop in infusion. Cmax arrives when you stop infusion, and then you have taken the sample Cpeak at 8:30 in this case. Here you see. So your delta T would be what? 30 minutes or 0.5 hour. So always you see here, you started at 7:30, you infused for 30 minutes infusion, and you take the sample. So sorry, you stopped here. When you stop, Cmax will come when you stop, and then you take sample at 30 minutes later after stopping. So it is 30 minutes. Most of the time it is going to be 30 minutes, but you do not believe me. You don't have to believe me, you just have to check always this, if it is delta T. So for the first dose, this is first dose, so you use 0.5, other things are same, and at steady state, here is your Cpeak. Is nothing, is just Cpeak here, and at first dose your Cpeak is. Same is true for Cmin. In case of Cmin, timing is somewhat different way. What we know, if you go back to Ctraf, so this is your time. This would be your delta tau. So when Cmin comes, if you remember, Cmin comes when you are going to give you the next dose. So in this case, here in our case, you have taken sample at 3 p.m. but actual time of the dose end is 3:30 p.m. So here it is your C trough. It is your C trough. Here is your Cmin. Cmin means at the end of the dosing interval. So if you have taken sample at 1500 and your Cmin end of dosing interval is 15:30. So in this case again is 30 minutes. So always you have to remember it is the difference between sampling time and the end of the dosing interval. Difference between the sampling time for C trough, for example here, in this case dosing interval, these are dosing interval. End of dosing interval is this, end of dosing, and in this case the sampling, you took sampling at sampling time, so that difference will give you delta t. So I will ask question to calculate delta t only. So if you know the delta t, you see here, it's easy. Delta t is 0.5 and you have to use C trough, which is this one, and in this case Cmin at steady state, again C trough, and then time is set. So this is easy. Another important concept you have to remember, to calculate V we use this equation, remember, but in this case, in case of bolus dose, it is C0 is correct, so bolus dose, but in case of short IV infusion, intermediate IV infusion, if we use Cmax, this is your Cmax, you see there is a big difference between the time. You see here, this would be, you'd consider C0 in case of bolus, but in case of intermediate Cmax. So which is smaller? Cmax is smaller than C0. If you use this, if you use Cmax for short infusion as your C0 and you calculate V as, so you will have a larger actual V. This is a concept you have to remember. If you use Cmax, if you always look into this graph, if you look into this graph, this is C0 in case of, but in case of short infusion it is going to be Cmax. One of the problems with short infusion is that when you are during the infusion time, some of the drug gets eliminated. For this reason Cmax usually smaller than C0, and when you use this to calculate, your volume distribution is going to be less, or it's called inflated volume distribution. So for this reason, volume distribution, we have two equations, one for the first dose, another for the second dose. Here volume distribution after the first dose, use this equation, K V is volume distribution, R, and then this is the T infinity infusion time here in this equation here. T and F is the length of infusion time. In our case it is always 0.5 hour or 30 minutes. So here you rearrange this equation by, you can use this, this would be a V at steady state. If you go back to the equation sheet, you will see that here this is one of those equation, V at first dose and V at steady state. So difference between these two equations, V at my first dose here, you see there is another component, E1 minus e to the negative tau. Always you remember steady state is different. So here V would be in case of steady state, you use this equation. Always you have to remember, in case of steady state it will give you accurate V, or if you could use dose plus C0 is going to be an estimated V, which is going to be a little smaller than accurate one. So I will show you in the class what is happening. Dose divided by C0, but in this case V is different. You have to calculate V considering concentration, how much drug is going out of the body, all this you have to consider. So now in case of here volume distribution, there are number of derivation of this equation, but here is the equation. You can write this equation that way, and then there is also a universal equation. It's called this one. This V is equal to, this equation can be used for first dose and for both steady state. For when you use first dose, this pre-dose, this would be 0, but for steady state Cmax and pre-dose will be equal to Cmax at steady state and Cmin at steady state. But most of the time you use this equation. Here you go. Cmax after the first dose, you can derive this equation. You can find that V using this equation, or here this V. This is at steady state, and this equation would be at first dose. And there is little difference between first dose and steady state. I will explain this in the class. And finally, as I have mentioned, approximate equation for estimation of V in clinical practice. Equation for V after intermittent IV infusion are complex, and so that's why a simplified form of the equation is used. This equation for the first dose data, we can use the equation IV volage, assuming Cmax is equal to, although this will give you a big or inflated V. For first dose we use this, and for steady state we will use this one. And this error is going to be high when this difference is, so overestimation of V is going to be higher when C0 minus Cmax is big. Then the overestimation will be also, you see, overestimation of V will increase with the increase in the value of this difference. Again, if go back and check that if you use this equation, this will give you an approximate V, but and if we use, if you want to use approximate accurately, you have to use that equation to calculate accurately V. So now, and some I want you to go over this this simulation. Just you want to check how dosing interval influences the concentration, various concentration. So what would be the possible question? I will ask you to find T. For example, you start infusion at 7:30, stop at 8, collect sample 8:30. What is delta T? Why C0 instead of Cmax will give an inflated V in case of intermittent infusion? I have explained that why, because C0 is usually larger than Cmax, so that's why it is going to give you an inflated. overestimation is related to C0, overestimation when C0 minus Cmax increases, there will be more overestimation of V. Still my stopwatch didn't help much. It is now 15 minutes 20 seconds. I will stop here. So I'll see you tomorrow in the class.